Hello everyone, thank you for coming. In this session I will be talking about dbExpress connectivity to SQLite. SQLite is a popular embedded database and is one of the most widely deployed database engines out there. First of all, my name is Blas. I'm an R&D engineer for Embarcadero and I started with Borland in 2002. What will I be talking about today? I'll be talking about the SQLite driver and metadata, discussing some features of SQLite that I found interesting, and demonstrate building DBX applications that target SQLite. In Rad Studio exe3, we provided a dbEx4 driver for SQLite. It is written entirely in Delphi, so you can link it directly into your application with no need for an external DLL. The source code is provided. We support its use in both Delphi and C++ applications that target Windows 32-bit, Windows 64-bit, and OS X. It can be used in the same manner as other DBX drivers, so it should be pretty straightforward to build an application to target SQLite, especially if you have built a DBX application before. The key driver unit is data.dbx SQLite.pass. As you can see, it is a dbEx4 driver, as it is made up of classes that descend from the base classes in data.dbx common. It contains a tdbx driver, tdbx connection, tdbx command, tdbx row, tdbx reader, and tdbx transaction descendants. In order to design and deploy your DBX SQLite application, you will need the SQLite client. For Win32, this is available from the SQLite website at the URL that I have provided on this slide. For OS X, the client library will already be located in your user lib directory, so it should not require any action on your part. SQLite does not provide a precompiled Windows 64-bit client that I am aware of. However, they do provide the source so that you can compile the client yourself. Instructions on doing so are beyond the scope of this presentation. However, you can easily find out how to do it by searching sites such as Stack Overflow and tailor the compilation to your needs. Before I go too much further, I'll show you how easy it is to create a simple SQLite application from scratch. First, I'll create a new FireMonkey application, and I'll drop a T-SQL connection out of the forum. Choose the SQLite driver and choose a connection that I have pre-configured. Now I'll invoke the Live Bindings Designer. Use to link a grid. And I'll hook it up to a country table which has a few records and is similar to the country table in Interbase. And there you have live data at design time. I'll run the application, and there it is. Now I'll hook up a navigator and show some basic editing. Run the application. Post the record. And there it is. Data has been changed. There are a couple of connection properties that are unique to SQLite connections. The first property that I'll talk about is the column metadata supported property. This property allows you to control whether certain metadata APIs will get called by the driver. The SQLite client can be built with or without support for column metadata. If your client has been built without support for it, you will want to set this property to false. On Windows, by default, we set this property to true because the precompiled binary that you can download from their site supports it. On OS X, we default to false because the library provided in user-lib does not support column metadata. Since you can recompile the SQLite library yourself, we have chosen to provide this as an option. Another connection property that we have provided is the fail if missing property. This property determines whether an exception will be raised if the database you have specified is not found. By default, an exception will be raised. However, by setting the property to false, a new database will be created for you if the target database is not found. I've created a sample application to demonstrate this behavior. I've hooked up a SQL connection to a new SQLite database that doesn't currently exist. It's located in SQL and CodeRage. I called it test.db. Fail if missing is true by default. In the button click event, I just open the connection. So if I run the application with those settings, as you can see, you get a unable to open database file error. However, if I change fail if missing to false, this does not occur. And if I take a look at my CodeRage/testDB, it's now created. These are the data types that SQLite supports. There's SQLite integer, SQLite float, SQLite blob, SQLite text, and SQLite null. SQLite null will be there when there are no records in the table. Here are mappings for those data types. We map SQLite integer to the N64 type. We map the SQLite float to the double type. We map a blob to a blob binary. We map SQLite text and SQLite null to blob wide memo. And the reason we do that for SQLite text is that SQLite ignores any precision that you put on your varchar field. So if you declared a varchar 10, it would still let you store a string 100 characters in length. It completely ignores that. So we're using a wide memo instead. The metadata support in SQLite is fairly limited. There are some APIs to get column information, but not much beyond that. There is also a SQLite master table that contains information on table and index names. This table also contains the original string used to create the table or the index. One interesting side note on the metadata is the behavior when a table contains no rows. The metadata APIs return a type of SQLite null until a row has been inserted. The usefulness of the metadata can be further compromised by using dynamic typing, which I will discuss on the next slide. Next, I'll cover some interesting features that I ran across while working on the driver. First, as I mentioned before, SQLite supports dynamic typing. This means that it does not enforce data type constraints. You're able to insert strings into integer columns, for example. I consider this more of a curiosity, as I don't think it's necessarily a good idea to use this feature. One thing that I noticed when experimenting with dynamic typing is that if you attempt to insert a string into an integer field for the first row that you insert into a table, the metadata for the column will return a result that you may not expect thereafter. It appears that the first row that is inserted impacts the type affinity in some way. I've created a small demo to demonstrate the dynamic typing behavior. I just have a SQL connection and a button click event which creates two tables. Each table contains an integer field. In the first table, we'll insert an integer as we normally would. For the second table, I've chosen to insert a string just to demonstrate the differences in the behavior. So run the application, click the button. So now the tables are created, data has been inserted. So now I have these two queries. The first one is a select star from the first table, which had a integer value inserted into it. If I open the fields editor and I add all fields, the end field is of type T large end field. That's what the metadata told me, so it sets it up appropriately. However, for the second query, doing a select star from the second table, which had a string inserted into the field. When you add all fields, field comes back as T-wide memo field. So inserting data that was different from what we had declared had an impact on the metadata. SQLite also supports an InMemory database that only persists for the life of your application. It is not written to disk. You can leverage this feature by not specifying a database name. When you open the connection, you will be able to use the database normally. It will just go away when your application terminates. I'll quickly demo this feature. First, I'll do VCL application this time. Just drop a T-SQL connection onto the form. Set just the driver name. Don't specify a connection name. Open the connection. And I'll add another button click event to just create some data. I will display the data. Into a DB edit. That's an OK error because we haven't created the table yet. I'll run the application. there's the data. And we have no database persisted on disk. I don't know if locking is considered interesting, but I thought that I would cover it anyway. SQLite supports many simultaneous readers, but no one can write while others are reading. SQLite only allows one writer at a time. That's a simple overview of their locking. You can go through their documentation for a more detailed explanation. I will now demonstrate locking. So I've created a sample application which has a query that just selects data from one of the dynamic typing test tables that we created earlier. And in one button-click event, it opens the query. In the other button-click event, it inserts data into that same table. Now you'll see when I run it that this will work because it does not lock it within a process. What it does is it locks it so that a second process cannot come along and modify the table while process A is reading. So I will launch the second instance, and I will attempt to insert data. And as you can see, you get a database as locked error. So just something to be aware of. This could be an issue for you if at design time you activate a query and then you run the application from the IDE and attempt to insert data. You may hit this database is locked error because the IDE is one process which has opened the table for reading, and the application that you're running is attempting to insert data into that table, and it's a separate process. So it's just something to watch out for. I can quickly show this. So I activate my query here at design time. I run my application, which is a separate process. Attempt to insert data. Database is locked. So there you have it. We also have support in the Data Explorer for SQLite. So let's kill this stuff. This is the connection that we created earlier. As you can see, there's all the tables that we created. So you can get a list of tables. You could create a new table. I won't do that right now, but you could set something up. You can retrieve data from the table. And you can see the metadata of the table. It also supports drag drop. So if I wanted to drop a connection, just drag drop from the Data Explorer. If I wanted the table, drag drop from the Data Explorer. You've got your T-SQL data set hooked up. Pretty standard stuff, but SQLite supports all that. That covers everything I wanted to talk about today. Thank you for coming, and enjoy the rest of the CodeRage sessions. Please submit any questions you have, and I'll do my best to answer them. Thank you.
Okay, I'm just going to make a sort of a quick SQLite application in C++ Builder, VCL Forms. Okay, just drop the SQL connection on the form. choose the SQLite driver. And I'll just choose this connection that I've pre-configured. And I'll just kill the login prompt. We don't need that for the purposes of this demo. Get my SQL data set set up. I have a table that I had created earlier in the day. Just wiring everything up here. And there's some data design time, and also do it in button click event as well. And there's some data from SQLite and that in a C++ application.
All right, cool. So we have a bunch of questions here. Have you ever successfully compiled the SQLite 64-bit driver from source using C++ Builder?
I haven't tried that yet, but I think that's a great idea. I think it would be a good test of our compiler.
So if you got some time, you can take it for a spin and blog about it, maybe.
Absolutely.
All right, cool. Let's see. I'm not sure if dbExpress can easily be used in a live multi-user project. Not sure what that question came, what it was in relation to, but dbExpress is fully multi-user.
Mm-hmm. Yeah.
Okay. Another guy thinks that SQLite really doesn't seem very robust. Why or when would I use it? Thought that in-memory table did seem good for quick holding of data, though.
One place it gets used a lot is on mobile devices. So that would be one place, and we're working on our mobile support.
So if you want to keep the database the same on the mobile devices on the desktop, you could use SQLite.
Yeah, absolutely.
Okay. Where would I find the 64-bit Windows SQLite DLL on the macOS dialib?
The 64-bit SQLite DLL you'll need to build yourself. You can download the source for SQLite from SQLite.org. And when I was testing out our 64-bit support, it was pretty easy to find some information on how to build it 64-bit. It probably took me about 5 minutes of searching, and it worked quite well. So it should be pretty easy to find. The Mac dilib is will be on your Mac machine in user lib. It's called lib SQLite3.dilib.
Is that so? That's pre-installed on the Mac, both 32 and 64-bit, or?
Or
do you have to build those yourself too?
The 32-bit is pre-installed on the Mac. least for a bit, I'm not sure.
Okay. We can probably find the sources and build them for the Mac same way.
Yeah, I would guess it's probably there.
Okay.
I'm not 100% sure.
Which version of SQLite do we support for dbExpress?
We support, well, we're mostly tested against, I think it was 3.7, but we support, 3.x, essentially.
And where should you place the SQLite DLLs once you actually download or build or whatever for 32 and 64-bit? I always get lost in the world of System32 and just wow, 64 subfolders, etc.
Pretty much anywhere that's in your path, should work. System32 is typically for 64-bit DLLs, and SysWow 64 is for the 32-bit. So the numbers are
confusingly reversed.
Yeah,
right?
Yeah, unfortunately. But so those would work. But anywhere that would show up in your path should work as well.
What do I need to deploy with a C++ Builder SQLite-based application? dbExpress driver? Do I need to deploy the SQLite DLL as well?
Yes, you'll need to deploy the SQLite 3 DLL that's that you can download from their site.
Okay, so 32 or 64, depending on the application, of course.
Yes.
How would you use SQL tables to deal with a variable length data string read from an external file? So SQLite, does it have varchar or something like that? Or?
Yeah, it has string fields. So I guess I would use those.
I think I remember that there's a trick needed when I create my SQLite database first row of data in order to get the right field types in C++ Builder. Is that correct? When you create a table from scratch?
Yeah, it it lets you kind of sets the type affinity so that when you get the metadata for the table, it knows what what data is intended to go in a particular column. I think I covered in my presentation that you could declare a field as integer but put strings in there, and that actually works, even though I'm not sure why you would want to do that, but it allows it because of the dynamic typing system.
So the driver does the conversion, or is it the SQLite itself?
SQLite does it itself. If the string, if you have an integer field and this string you put in is an integer, from the documentation it says it'll coerce it to an integer, but you could put something like foo. That would take it well.
Oh, you don't get an exception back? Oh,
it just works. So it's a feature, I guess.
It translates foo into $F00, right? No, just kidding. All right, any other questions? Please feel free to put them in. Anything you want to add, Stephen, at this point?
No, I tried to cover as much as I could think of in my presentation. Hopefully it was somewhat informative to people.
Yeah, and I know your presentation actually didn't have there wasn't a ton of Delphi code, so it was mainly setting active to true and stuff like that. So even if you watch the replay, it's not very hard to translate from Delphi to C++ for this particular session. Will dbExpress be updated as SQLite is updated?
You mean the driver?
Yeah.
That would be the plan.
Okay.
We would update it as new versions are released, and if they have new features that we need to support.
All right. Thank you very much, Stephen.